All right, guys. So what I'm going to do today is I'm going to go over the lab with the air masses in the fronts. Okay. Sorry that I kind of pushed this back a little bit. Had to get some stuff done this morning and this afternoon. Um, Hopefully you guys are doing well. So I'm going to go over these 6 questions. Okay. So the first one says, how do front boundary symbols show the direction of movement? Okay. So remember, um, basically you have 4 different fronts. Okay. You have your cold front, you have your warm front, you have your stationary front, and then you have your occluded front. Okay, so I'm just gonna draw these pictures right here. Here's our 4 different types of fronts that you find on a weather map. Okay, so basically it's asking you, how can you tell which way the front is moving by the direction of the symbols? Okay, so what I'm going to do is just to make this easier, I'm going to make my little compass up here just to show you guys and basically just go over it one more time. All right, we got north, south, we got west, we got east. Okay, so the fronts, the symbols actually point in the direction that it's going. All right, so if we're looking at this cold front, symbols are going this way, so it's actually moving. The cold front is actually moving east, so we could say east. All right. Now this warm front, I kind of put it on an angle. You could say that it's moving northwest. This stationary front is a little bit of a trick question. So stationary fronts, they're kind of staying in the same area because they're both crashing. You have the cold front, which shows their symbols going, basically, if you looked at the compass, southwest, all right, because these arrows are going this way. And then you have the warm front coming the opposite direction, going northeast. So stationary front doesn't really move, okay? So not moving. And again, I mentioned it on the last video, when you're thinking of stationary, think of a stationary bike where you can pedal all you want, but you're not moving from that location. And then you have an occluded front where a cold air mass catches up with the warm air mass, but they're still going in the same direction. So for this, since I'm at a little bit of an angle, we can say that this is going northeast. All right. So for number 1, you don't have to draw these pictures, but I'm just showing you that the symbol points in the direction that the front is moving. So you can use something like that for your answer. Okay. So that's for number 1. Now, number 2 is asking about cold fronts. Where does precipitation occur? So precipitation, when we're talking about precipitation, it's anything. It could be snow, rain, sleet, hail. Sometimes it forms thunderstorms, okay? So I'm going to get rid of my fronts. And now I'm just going to put in a cold front. So I'm going to use blue for this. So I have my cold front moving in. All right. So the cold front is actually the very front of it. Hence the name cold front. All right. So we're right here. Now we have warm air. And remember, with warm air always wants to rise. It is less dense than cold air. So when this cold air comes in, it's going to push up this warm air really quick, right at the front of the cold front. So this warm air is going to rise up right at the beginning of the front, and it's going to form those clouds. So that's where that precipitation is going to occur. So for a cold front, the precipitation is going to occur right at the front. And we're going to talk about the densities with this for question number 4. So cold air comes in, It's a lot more dense. It's going to push up that warm air. Precipitation is going to occur. And then you have your heavy rainfall all located in a small amount of area, okay? Because it's pushing up all that moisture. It's condensing. It's forming that cloud. And it's only in one little area right at the beginning of the front. So you're going to get a lot heavy rainfall, okay? So that's for number 2. Now, if we change this for number 3, where it says, with respect to a warm front, where does precipitation occur? We're going to put our warm air moving in. Got a warm air mass. And now we have a cold air mass. Okay? So when this warm air mass hits, all right, so let's say this is the beginning of the front. It hits the cold air, but what happens is the warm air cannot go underneath it. It's not pushing up that cold air. Instead, the warm air continues to move, and it's going to actually go on top of the cold air. It's just going to keep going up. And because it keeps going up, it's going to eventually start forming those clouds over here. All right, because it doesn't get pushed up right away. It kind of goes over it. Cold air sinks because it's more dense. Warm air starts to rise, but at an angle. So since it does that, you have precipitation spread out over a much larger area. So it's less precipitation because it's spread out, and it's ahead of the actual warm front boundary. So when you're answering question 3 with respect to a warm front, where does precipitation occur? It happens in front of the warm air mass. Okay, and this is what gives you this gives you light precipitation. Okay, and remember, just because it's warm air doesn't mean that this doesn't happen during the wintertime. If this happens during the wintertime, instead of having, rain, you'll just have a light snow flurry. You won't have, a cancellation of school because it's not really hitting hard. It's just spread out. You'll have a little flurry, and that'll be it. So that's for number 3. Okay. So now number 4 is talking about densities. So when we're talking about densities, I'm going to draw basically the same picture that we did before. We got a cold front moving in, and then we have a warm air mass. So when that cold front comes in, it's more dense, so it's going to sneak underneath this cold front. I'm sorry, this warm front. And because of that, it's going to move this warm front up. And just like I basically drew in question number 2, it's going to form those clouds, and it's going to cause heavy precipitation. But question 4 is not asking for that. It's asking, how does the density play a part in determining how unlike air masses react? So for this, basically our cold air is going to sink. Okay? And our warm air is going to rise. And we'll even draw up a picture of a house. All right, let's say this is a room in your house. Now, if you have central air, all right, usually you have it located on the ceiling, or let's say you have a air conditioning unit, okay? Usually it's located on the side, but up top. The reason for this is because cold air sinks. So if you're over here, and we know that cold air sinks, this is how you cool off your house during the summer. All right, it comes down and it hangs out over here. If it didn't sink, all that cold air would just basically hang out at the top of your room. And in this case, you would still be warm because all the cold air is at the top towards the ceiling. Hey, Brian, how are you? I'm sorry I couldn't do the 7th grade tonight. Today, I'm going to post the questions right after this video. I just got home. So the same thing happens with heat in your house. So if you think about your house, usually you have your radiators or your heating units usually located on the ground, okay? And the reason for this is because warm air rises and it goes up. And then eventually it cools and it falls back down and then it gets heated up again. And then you kind of have the same method that's happening in the Earth's core, in the mantle, right? Where you have the magma heating up, it's going to the surface, the density starts to die out as it cools off and it comes back around. Those are our convection currents that we were talking about when we were doing plate tectonics, okay? It kind of looks something like this. So the same thing happens in your house. Now, if warm air didn't rise, it would just hang out at the bottom and only your feet would be warm, but the rest of your body would be cold in your house during the wintertime. So that's kind of the same thing that's happening in the atmosphere with cold fronts and warm front, and when cold air masses collide with warm air masses. Okay? So for number 4, basically all you need to know is cold air is going to sink, warm air is going to rise. And this is true with magma. Even think with the pool, right? If you jump into a pool and you go to the deep end and you go really down to the bottom, the water at the bottom of the pool is going to be a lot cooler than at the top because that warm water is going to be on the surface. Same thing if you go to the beach. The further out you go, where it's deeper, and you go down, it's going to be a lot cooler at lower depths. Okay, so number 5. What type of weather front experiences a decrease in temperature? So this one's right in the name. So if we're doing a decrease in temperature, it's going to be a cold front. Because remember, if we have a cold front coming in and it's moving east by our compass, everything behind here is colder than the temperature over here. This is going to be a higher temperature. All right. So for number 5, it's short and sweet. You could just say it's a cold front coming through. And again, it doesn't have to be anything crazy. Let's say it's still pretty chilly on this side. Let's say it's 40 degrees Fahrenheit. So 40 degrees Fahrenheit, still pretty cold. You're still going to be wearing a jacket. This could be fall time. It could be, still winter. But everything behind here, this could be 32 degrees Fahrenheit, which could bring in snow weather because water freezes at 32 degrees Fahrenheit. So it doesn't have to be anything different. Now, you could also, during the summer, a cold front could be possibly, 70 degrees. Whereas the higher temperature, you could have a really hot summer day where it's 96. So just because it's a cold front doesn't mean it has to have freezing temperatures. It could just be a cooler temperature than what the warm air masses towards the east would be. And that's if it's moving this way. If I flipped it around, it would just be, the temperatures would be flipped. Okay? All right, so now you got the conclusion question. So for this, I'm just going to make a diagram, but I want you guys to kind of write it out. So for the conclusion, it's asking you, compare the temperature and moisture conditions on either side of a cold front. So I'm going to draw another cold front again. So it's coming in. You got your cold air. Remember, the front is right here. So if you actually wanted to draw it out, that's where your cold front is coming in. It's heading east. So what's going to happen is with temperature, which we just kind of answered for number 5, the temperature on this side is going to be a lot colder. So you have colder air. And on this side of the cold front, you're going to have warmer air. Now, with the moisture, warm air is able to hold more water vapor than cold air. So you're going to have less moisture on the left side compared to this diagram with the cold front. Now on this side, you're going to have more moisture. Okay? That's how sometimes over the summer you'll have really humid days where all that water vapor is in the air and you kind of feel sticky. Whereas when it's cold out, it's like a really crisp, really dry air because there's less moisture in the atmosphere around you. Okay? And remember, all of this is happening in the first layer of the atmosphere, okay? The troposphere. There's very little moisture in the next layer of the atmosphere, which is the stratosphere. And then as you go, the mesosphere and the thermosphere don't have any moisture. That's why all of our weather is happening on the first layer of the atmosphere, okay? So that's for the conclusion question. So again, I made this due on Monday. I do realize it's a lot different doing a lab at home. So if you can't get it in by Monday, try to get it in, because as long as you're handing in stuff, it's only going to help your grade. What else? So after this, we're going to do, on Monday, we're going to be talking about greenhouse gases and climate change. It's a little bit shorter of a topic. And then by the end of next week, we're going to be getting into astronomy finally, okay? So we're going to be talking about Earth's rotation around the sun, revolution, how it rotates, okay? Moon changes, the phases of the moon, how it affects the tides. And this is really important for us because since we live on Long Island, we experience the effects of the tides a lot more than other areas of the country. Okay, because we're surrounded by water. So the tides are really important for us to learn. So that's all I wanted to talk about today. On Monday, we're going to get in. So basically, the only thing is for the weekend, try to get this lab done. If you owe me anything else, please get that in. If you have any questions, please send me an email, okay? Next week, I'm going to try to send up a Zoom. I will update you guys on Google Classroom. This way we can actually, you guys aren't just looking at me. We can actually see each other and ask questions. So I will keep you guys updated with that. All right. I'll see you guys later.